Welcome back, and in our previous lecture we have learned the basics of friction, and in this lecture we are learning some special problems based on what friction concepts. Okay, yes, okay. The first famous problem we talk based on friction is called like a rope problem. Okay, rope or chain problem. Very important problem. It was repeated even many times in different exams. So what they do here, they say there is a table and one chain or rope is placed over this table like this, right? Yes. So the length L is the length of this rope or chain, length of chain, and M is the mass of chain, correct? Now what happens, suppose you put a chain like this way, some part of this this is a table, okay, first thing, right, table. So it's placed on a table such that some part of this chain is what hanging below the table, this part is hanging below the table and this part is placed on the table, right. So suppose there is no friction, just smooth surface, then if you do like this one, even you hang a very small part here, this chain will slide down, correct, if no friction is there. But if friction is there, then this friction force acting here will try to stop this chain sliding downward. So we are interested in knowing this, that what maximum length you can hang here, right, below the table, so that the chain remains stationary or does not slide down. So you have to calculate what is the maximum length we can hang below this table so that chain will remain stationary or it does not slide down. Okay. So total length of the chain we calling L, how much we can hang down, that's we calling Y, correct, total mass is given M. So one simple thing is what, okay, first what we are calculating, the maximum length that we can hang below the table, right, so that the chain remains stationary, or you say does not slide down, okay, does not slide down, correct. Very simple and very interesting question. So some frictions there and coefficient of friction will be given to what, mu, because this answer we have to give in terms of what, mu, coefficient of friction, correct. Yes. Once more I am telling, suppose there is no friction, then you hang here small length or big length, in all cases this will slide and fall down, right. Yes. If friction is there, the friction force acting at this will try to stop it. Okay. Now let's see, we are interested that you will see that this much part of this chain is pulling the system downward. So we are interested in knowing what is the weight of this much part, correct na? What is the weight of the Y length of this chain, okay, weight or mass you can say. So let's calculate first mass of this much part, correct na? Let's call that My, or M dash we want to call, let's call M dash. M dash is the mass of this much part only, from here to here, how much is what hanging below it. So M dash is what, mass of chain, mass of part of chain hanging below the table, or simply is this mass of that Y length of this chain. So how to calculate that mass? We know that mass for a linear thing or linear rod, uniform rod, is simply always proportional to what is length. Mass and length are what, proportional, correct na? Mass of the whole rope is what, less we said M, and mass of small part we have to calculate, they are directly proportional length, correct. So what is the length of when total mass M we writing, total length is what, L. We want to find mass of small piece, this piece we calling M dash, so here length becomes how much, Y, correct. Yes. Okay, so you will see from here that M dash is nothing but Y by L into what, M. This is the mass hanging below. Similarly, we have to find the mass of this much piece also, correct. Let's call M double dash, mass of part of chain on the table, correct. M dash you call how much hanging below this table, and remaining is what, on the table. So this you can do a same calculation again, M by M double dash length is what, L. Here length is what, this length is how much, L minus y, because this is y we calling, so that become L minus y. But you don't need to do that much hard work, because simply you can find m double dash is what, simply total mass minus your m dash. Total mass of the rope minus this much mass, you subtract, you get mass of that much part, right? We will need this in calculation, so I am calculating first mass of all parts. So this simply becomes how much? M minus m dash. M dash you have calculated here, y by L into what, m. So you take m common here, become 1 minus y by what, L. Okay, this will need 1, this will need 2. Correct? Okay, now what we will do? So yes, we want to keep this chain stationary, right? So how this will be balanced? The weight of this much part is what, pulling the system downward, and the friction force acting on this much part will try to stop it. Okay, so what you need, that friction force acting here on this part, let's call that F. If does not slide down, means what, you want to create equilibrium, means frictional force should be equal to what, weight hanging below the table, right? Your frictional force acting on this part should be equal to the weight hanging here, right? So what is frictional force formula? Frictional force is called mu into what, N is equal to what, the weight of this much part. What is weight of this part? Mg, m dash into what, g, correct? Yes. Okay, mu is okay. What is normal reaction? Again mg, correct? But here mass of this we are talking, right? Normal reaction here. So m double dash, correct? M double dash, and m double dash we have calculated here somewhere. This is m double dash, correct? No? Yeah, which becomes m 1 minus y by what, L into what, g. This is what, frictional force, mu into n. N is equal to what, mg, that m we calculated here into g. Now m dash also we know, that's what, y by L m into what, g. So you see m and g both terms get cancelled. So we have to calculate here y, what is the maximum length we can hang. So let's solve this. When you multiply that, it becomes mu y by L is equal to y by what, L. Let's take y term on same side. So mu should be equal to y by L plus mu into y by what, L, correct? Mu is equal to, here you take y common, we got, what we got, 1, okay, what you take, y by L we take common, 1 plus what, mu. So y we want to find, what should be y answer? Mu divided by 1 plus mu, okay, into what, length. This is the maximum length we can hang from a table, okay, it's called free end, so that this chain remains stationary or does not slide down, right? So that's the answer of this. You know, the same question will be asked in our next chapter when we learn work energy power. This question will be asked, that how much work is required to pull this hanging part on the table, right? Similar question we will see exactly, but that will be based on what, work energy principle. Here right now we are learning force, Newton's laws we are learning, so force concept we are applying. So they are asking that how much part it can hang below the table so that this rope does not slide down or chain does not slide down. So friction force acting on this part, which is, this is placed on rough surface, right? So friction acting here is trying to stop this chain in going downward. So this is the weight which is pulling the system downward, and the friction force here trying to stop it, right? Okay. Okay, let's move to the next problem. Next problem talk your insect and ball problem. Insect and ball problem, right? Yes. So here what happens, always there is a hemispherical ball. This is a hemispherical ball of some radius r. So what happening, there is insect at the bottom of this, he start climbing. So at some point he will slide and fall down, right? Suppose he reaches up to what, that height, okay, then insect slides down. So look here, we are interested that how much this insect can climb before it slides down, okay. So this again a rough bowl, because if smooth then he cannot even climb at all, right? So he is climbing because of friction concept. So insect is what, suppose here from this point he slide down. So let's give some name, that's the radius r, okay, and this is the height h. Let me use different color. Suppose this is the height from ground which you are interested in calculating this, that at what height the insect will fall down, and this height from the center you can call some name y, that's center what O, that's the radius r, this is also complete radius r, right? Y plus h will be radius. Okay, so when this insect is at this point, is about to slide at this point, we are interested in knowing what force is acting on this insect. Suppose he is making an angle of what, theta with the vertical, this is the angle, okay, yes, okay. So insect is here of mass m, right, let's write. So this is what mg straight downward, mg force, right, correct. He is trying to slide down, so friction force will act along the tangent like this. So this is your frictional force F. Okay, okay. Normal reaction will be perpendicular surface, means along this direction, toward the center of this ball. Let's call that N. Correct. Okay. Now let's write the component of mg along that direction and along that direction. Right. Okay. Yes. Okay. So let's write the component of this weight along that direction becomes what, mg cos theta, because this is what your theta again, alternate angle with that line. Okay, this is a slant line, vertical line, so these two are what, alternate angle, right? So same angle only, sorry. Okay, and component along tangent to this surface is how much, mg sin theta, correct. These are the forces acting on that insect who is at this point right now. Okay, let's write equation. What is the equation along the tangent? So tangent, we have frictional force here upward, so frictional force should be equal to what, that force, which is what, mg sin theta, equation what, 1. Okay, along this radius or to the center, that equation is what, normal reaction is equal to what, mg cos theta. Let's divide this equation. You say 1 by 2, we get f by n is equal to what, tan theta. Now what is frictional force formula? We know, right, mu into n. Okay, let's put here frictional force also called what, mu into what, n by n is equal to what, tan theta. So n get cancelled, so tan theta we getting simply equal to what, mu. This is the equation number what, 1. Yes, this relation already we know that tan theta is what, mu. Okay, now so we are interested in calculating that height. What is the maximum height this insect can climb? Okay, let me write this question also here, like I wrote there. Find the maximum height an insect can climb in ball before it slides down. Okay, yes, what is the maximum height it can climb before it what, slides down. Okay, this is equation 1. One more equation I need in terms of tan theta using geometry. So I am writing by geometry. Okay, by geometry, what is tan theta? Tell me in this equation. Tan theta is called always perpendicular by base, right? So if you watch in this triangle, let me highlight with different color. So this triangle you are watching, right? Watch in this triangle, what is tan theta? For this angle, that side is perpendicular, that side is base, correct? Na? So we need to calculate first this side. What is that? We don't know, so we can calculate in terms of r and what, y. So that becomes simply using Pythagoras theorem, r square minus y square and root, right? So I am writing directly here, tan theta should be equal to this side, which become what, root r square minus y square divided by this side, which is what, y. Let's call this equation number 2. Correct? Yes, this is equation number what, 2. Now let's equate these two equations, equation 1, equation, because both giving what, tan theta. One angle we find using these force equations, one angle we found by what, using geometry. So when you equate them, you say equation 1, okay, forget these names, 1 is equal to 2. I am equating what, these two equations. Okay, I should give different name if you are confused, because I already wrote 1 and 2 there. So this I give suppose 3, this I give as 4 name, right? Then 3 is equal to 4 you make. Okay, what you will get? Mu is equal to what, root of y square, sorry, r square y square divided by y. Let's calculate y here. Y is unknown, so square on both side. When you square on both side and take y on other side, becomes mu square y square is equal to r square minus y square. Okay, from here we have to calculate what, y. So this y terms on this side becomes y square, 1 plus mu square is equal to what, r square, or you see y will be simply equal to how much, r upon root of 1 plus mu square. Let's call equation 5. This is y, which is unknown. Now we have to find h. So if you see in this equation, this is a total r. So h is what? Simply r is what first? H plus y. We have to calculate h, which is r minus y. So from geometry again, saying h is nothing but what? R minus what? Y. This is the last step we are doing. So h is equal to r minus y is here, r upon root of 1 plus mu square. So you see h is nothing but r you took common 1 minus 1 by root of 1 plus mu square. Correct. So that's what your height, the maximum height an insect can walk in a bowl before sliding. Correct. So we have done the problem based on what? Like a rope or a chain placed on a table and that insect and bowl. So third type of question we are doing, like they ask like blocks against vertical wall. These type of question also has been asked to us. Okay. So here what they do, they say like a block is held against a wall. There is a vertical wall. I put a block here, then I have to apply force here to hold it what? Stationary, right? So yes. So some question they ask, they can ask you what is frictional force acting, or what is the mass of the block, weight of the block, normal direction. These questions will be asked to you. Same procedure only we follow. Let's see some example. Suppose they say a block of mass, some mass is given 0.2 kg is held stationary against a vertical wall as shown in figure. Okay. Calculate frictional force acting on it, right? Yeah, we have to calculate what is the frictional force acting on this wall. So look here, suppose this is your wall and a block we are keeping like this way, right? So if you want to keep this block of mass m, you have to apply a force here like this. Say here some Newton, 12 Newton. Okay, correct. Force is applied. So in this case they are asking what is the frictional force acting. So understand how forces are acting. This is applied force, external force. So mg will be straight downward only. This is mg weight. Then frictional force will act what? Upward. Why upward? Because this block is trying to slide downward, right? We are putting against a vertical wall like here. So try to slide down. So frictional force will act what? Upward. And normal reaction will be like this way, perpendicular to the surface like this one. Okay. We have applied force like that way. So reaction will be like that way. So what will happen? Always this force, if they are stationary, these forces will be equal. Like a direction will be, or we write generally n symbol, doesn't matter. Your reaction will be equal to the what? That force applied, how much? 12 Newton done. Correct. If they ask what is reaction at the wall, or the force applied by the wall on the block or by block on the wall, both answer is what? 12 Newton. Then you see upward frictional force should be equal to the weight of this block mg. Correct. Okay, F is equal to m is given, how much given? 0.2 kg into what? 10. So that become what? 2 Newton. This is the force applied by what? By the wall on this body. Frictional force they are asking, sorry, yeah, frictional force. Okay, not normal direction. Normal direction is what here? Okay. Yes. So this is only simple answer. Let's see one more question. Suppose they ask like this way. A block of mass m is held stationary as shown in figure. Calculate mass of block. Okay. So similar problem giving, this is a wall and some friction is here. There is a block of mass m and we have applied force here, say 10 Newton. Okay, and let's say mu is given, say some mu will be given 0.2. Let's take mu as what? 0.2. Correct, no? So with the wall there is a friction here and this is given how much? Mu is given as 0.2. We are interested in knowing that what is the mass of this block. So let's write all forces. 10 here, normal reaction will like this one, and Okay, mg will be acting straight downward, friction force will be acting what, upward. So friction force should be equal to what, mg, equation 1. We don't know m, that you have to calculate, but you know frictional force also main formula is what, mu into what, n, correct. And let's say what is n here, n is equal to what, 10. Don't write n is equal to mg in this case, no, correct. Mg is what happens when you put horizontally, then you see reaction n is equal to what, mg. Not in this case, normal reaction like that way, mg acting what, downward, right. So normal reaction is equal to what, 10 Newton here. Okay, so we want to find F is equal to mu into n. So F will be equal, okay, sorry, let's calculate this. F, mu is given 0.2 and n is equal to what, 10. So this becomes what, 2 Newton. So this is a frictional force that you can put in this equation. 2 is equal to what, m into what, g, or m is equal to 2 by g means 10 means 0.2 kg. That's the mass of this block, right. Yeah, this type of question they ask. So to keep this block stationary, we need to apply a horizontal force here. So normal reaction at the surface between this block and wall will be always equal to how much force we have applied, right. Yes. Okay, to hold this stationary, the frictional force should be at least equal to the weight of the block, then it remains stationary here. Okay, yes. Okay, so now we will do a special problem based on this frictional concept, that's called mass over a mass. We have learned mass in contact, like they are placed on a horizontal surface or inclined, but we have not learned one mass is placed over other mass and they are moving, they are accelerating, then we have to calculate frictional force between them and acceleration of the blocks. Okay, yes, let's talk about those type of questions now. Okay, we are doing now last type of questions based on friction. So far these type of questions they not ask much in our NEET exam, but they were asking in what, JEE exam, so we will do little practice on them. Okay. So these are called we can give some name like two block problem. There are two blocks, place one over it, right. Okay, so we'll understand this, how to solve this type problem with help of directly example. Let's say some example is given to you like calculate the acceleration of each block. Okay, there are 3-4 questions are possible here in this type of question. They can ask you acceleration, they can ask you frictional force, these type. Okay, so look here, some picture is given to you. Suppose two blocks are placed like this way. This is one block, say 5 kg, and another block, this, let's say this is 10 kg. You can give name also like m1, this is what, m2, and they are placed on a surface. So this surface can be smooth or rough, but I am talking neat, let's make it easy, maximum time it will be smooth only. So this surface less what, this surface is what, smooth. Okay, I am saying this surface is what, smooth. Okay, and there will be, this surface will not smooth, some friction will be given between these two blocks. Okay, so let's say here some mu will be given to you. You can write 0.54, anything your choice. Okay, this is mu given, and force on any one block will be applied. Let's say this here force is applied something, say 15 Newton, correct. Two blocks, place one over it. At ground friction is not there, smooth surface. Between these two blocks there is friction, mu is given, and force applied on this block is given. Now question will be this. First they can ask you, tell whether these blocks are moving together or not, correct, whether they moves together or not. We applied force on this, whether this block will drag that block with this or not. Okay, suppose they are moving together. Okay, they will ask you to calculate acceleration, or they cannot move together, they move what, separately, then their acceleration will be different. So that we have to calculate individual acceleration of block 1, block 2. Okay, yes. So we have 3 steps to solve these type problems, and very simple step. Let's see them what they are. Okay. So step by step we'll do. Step number 1, correct. First you have to check, you have to assume. Okay, so what you do, assume that right now we don't know that whether these blocks are moving together or they are moving separately. So in step 1 what you do, we assume that suppose they are moving together, then what happens. Okay, assume blocks moves together, they are moving what, together. So calculate the acceleration in this case, then acceleration common, will be what? Total force by what? Mass. What is external force applied here? Just 50 Newton. That's 50 by total mass what? M1 plus M2. That becomes 5 plus 10. 50 by this becomes 15. 15 goes 3.33 time you can write meter per second square. So what is step number 1? Okay. Suppose they are saying in words itself that they are moving separately, then you don't need to do these steps. They just, or they are saying that just calculate acceleration of the blocks, then you write these steps. Okay. So in first step you always assume less these blocks moves what together, then what will be the acceleration of this system together. Okay. This came like this much. Okay. Step number 2. Okay. In step number 2 we will know whether they moves now together or separate. That we will know. How? You write the FBD of the block on which external force is not applied. Let me write here. Draw or write FBD of block on which external force is not applied. So if you talk in this case, like on this block external force is applied, but here it's not applied, right? So you have to take the FBD of what? M2. So I am taking it here. FBD of this block I take 10 kg. Correct. We assume suppose this system is moving this direction with what? Acceleration A. Okay. So I took 10 kg body. Correct. Now let's write forces acting on this. Suppose this block is moving that direction. Okay, with acceleration A. So frictional force will act in that direction. F. Right? Correct only, because this block is trying to drag this block forward. So frictional force on this will act what? Backward, right? Trying to stop it. So now here you have to calculate two frictional force. Give attention here. Okay, see it. So we are calculating now two things. First thing, what is the frictional force or kinetic frictional force required to move this body? This body, okay? Yes. So frictional, should write kinetic frictional. Okay. What is the answer? Look here, two equation, two force we have in this direction F. This direction is what? Only MA. In horizontal direction we have two force on this body. Okay. Yes. Okay. So F is equal to what? M into what? A. Mass of this body is what? 10 kg. Acceleration we have calculated here 3.33. So this becomes 33.3 Newton 1. Correct. Right. Now you write FBD of the other block. Okay. Of other block where force is applied. Where this is step number 3 we are writing. I should write like this way. Step 3. Correct. Write FBD of other force, other block where external force is applied, right? So we are talking about, like in this case, that block we are talking, okay, 5 kg block, right? Force F here 50 Newton, correct? Okay. So what we have to do here, from here you have to tell that how much the maximum force available from what? This block, how much maximum force, frictional force this block can apply on this, because frictional force only dragging them, right? So you have to calculate what? Maximum frictional force available, right? Right. This is called what? Limiting frictional. So this is called what? Simply we are calculating what? Limiting friction. How much friction is available from this body, okay, to this body. So FL we writing, that's what, let's write mu into N. This formula you have to write. To calculate kinetic friction, writing MA by writing FBD of the block where external force is not applied, means that block in this case. So mu into N. Okay, mu is 0.4. N means what? Mg of this block, right? This block, this is N, that's what? Mg. So M is given 5 kg, G is given 10, correct? So this becomes how much? 20 Newton, correct? So you have calculated two acceleration of the block on which external force is not applied, and that is writing kinetic friction is writing simply MA. The writing equation what? Horizontal direction. Then you are writing FBD of the other block and calculating what is the maximum frictional force available from that body. That's called limiting friction, simply mu into N of that body. Now you have to check if, what is the condition now? Very, very important. If this frictional force, kinetic friction is either equal or less than this value, what do you write? If F is less than equal to what? FL. Less than or equal to FL, then it means what? The two bodies moves together. This is the main important condition, okay? If that kinetic frictional force is either equal or less than that value, then the two bodies will move together, otherwise they will move what? Separate. Or opposite, how you writing? Or if F is greater than FL, then the two bodies, two blocks moves separately, right? Now they will have different acceleration. So let's check in this case. Frictional force 33 and the maximum available is what? Just 20 Newton. Means this condition is what? Satisfied. Means two blocks will move what? Separately. Correct? Na? If they ask easy questions, then answer will be here itself. If the like suppose this value is less than that value, means the two blocks moves together, acceleration will be that one only, right? Here answer is done. But if this frictional force is more than that or equal, then this condition will be applied. Now you have to calculate individual acceleration. Suppose this condition is satisfied, then answer is what? This much only done. Two blocks moves together, acceleration of the two blocks will be same, and that's the answer here itself. But if this condition is there, that if frictional force is more than this limiting frictional, then you have to calculate acceleration separately. So in that case, right, like in this question, this condition is satisfied, right? The kinetic friction is more than what? Limiting. So this condition is satisfied, you have to calculate individual acceleration. So this step 4 you have to write in that case, step 4. So in step 4 you have to write what? FBDs, and you have to calculate individual acceleration. Let's see how. So we are writing step 4 to calculate the individual acceleration. And step 4 simply we have to write FBD of the individual these blocks again. So just write FBD of let's write first block. Which block you want to write? 5 kg block. You want to write FBD of 5 kg block. How it looks? This is your 5 kg block, and here force applied is what? 50 Newton. Acceleration, let's call it A1 in that direction, and frictional force F1 backward. This moving forward, friction force will be backward. So let's write equation. Net force is equal to Ma. So 50 minus F1 is equal to what? M1A1, right? Now give attention. What is the frictional force here? Maximum frictional force already we have calculated what? This step. Remember? This is the maximum frictional force acting between these two blocks. So here we put that value 50 minus 20 is equal to M15 into what? A1. So this becomes 30 by 5. That A1 becomes simply 30 by 5, 6 meter per second square. That's the acceleration of the first block. Okay. Then write FBD of 10 kg block. When write FBD of 10 kg block, how it looks? That's a 10 kg block here. I have drawn there also 10 kg. So what forces are acting? Is accelerating that direction with acceleration A2, frictional force, correct? So frictional force will act here F2. I think in this picture I wrote frictional force little wrong. Frictional force will not act in this direction, because it's trying to stop, so I should write frictional force here at this point, okay? But everything will be same, no change. Just the direction I wrote it opposite here. Be careful about that. Okay, so F2 should be equal to what? M2, A2, no other force are acting. Okay, frictional force maximum, these are same only, this one and that one, right now? They are acting between these two pairs. So that will be also what? Your 20 Newton, this value only you have to use. So thus 20 is equal to 10 into what? A2. A2 will calculate that was 2 meter per second square. That's the acceleration of this block. Okay. Yes. So let me quickly revise this. Actually, what I have done. So first thing I want to tell you that these type problem in NEET they are not asking much. Okay, should not worry. But if you want to learn them, then it's here. So two blocks will be given. One is placed over other. Force they applied. You can apply here. You can apply here. This force doesn't matter. Okay. Yes. They asked two questions. Either they asked to check whether, simple question will be like this, whether these two blocks are moving together or not. If they are moving together, calculate acceleration. If they are moving separately, calculate acceleration. So what steps you follow? First we assume step 1 that suppose this system is moving together, both blocks moves together. Let's calculate acceleration of this system. You apply net force, applied force by what? Total mass. Okay, this surface is what? Smooth. Okay, calculated. Step 2, you have to write FBD of the block first, which is what? External force not applied. This is the block where external force not applied. You write FBD and you calculate that what is the kinetic friction required to move this block. How much force between these two are required so that moves what? Together. That force is writing simply MA of that block because two forces are acting, frictional force and MA in horizontal direction, no other force. Okay, we calculated that's the frictional force required to move. Then we write FBD of the other block and check how much is the maximum frictional force available. Maximum frictional force limiting is simply what? Mu into N of that block. Mu we know, N of that block we are writing, which is what? Mg. We calculate 20 Newton. Now here you have to check if this kinetic frictional force is less than or equal to the limiting, correct na? This is the maximum frictional force available, correct na? Yes. If this value is less than or equal to that, then the two blocks moves together. Acceleration will be simply that answer only, done. Here question is what? Over. But if this frictional force is more than the limiting, then in that case the two blocks will move what? Separately. This condition will be satisfied. When they move separately, then you have to write fourth step. You have to write what? Individual acceleration you have to calculate. So you write FBD of any block. First block you write like top block here. So the forces acting, applied force here, frictional force backward, and acceleration here, right? Net force is equal to MA. But what frictional force you putting here? That limiting. This is the maximum frictional force you can have, that you putting what here? You calculated acceleration. You wrote the FBD of the second block. You showing forces here, acceleration and frictional force, only two forces are acting, right? So force is equal to what? Simply MA. Again this maximum frictional force, this and that are same only. F1 and F2 are same. We giving name like F1 for this block and F2, but the frictional force acting between these two blocks is same. You talk that block or that block. So that maximum value is what? Again this much only. So we have to put it here and we have to calculate the acceleration of the second block. So this is what? Two block problem. Okay. We will see one more example. Okay. Yes. So we are doing one more problem on this two block problem. Let's say problem number 2. Question says calculate acceleration of each block. Okay. Yeah, so some question is given to you. Suppose two blocks are given. This is a 10 kg block and is placed over another block of say 20 kg mass, and this is placed on a smooth surface. So here no friction. Let's say this surface is what? Smooth, and friction between these two blocks are given. Let's say here mu is given as 0.4 something. And last time I applied force on this block. Let's apply force on this block. Then what happens? Say some value 90 Newton. Okay. Question says calculate the acceleration of each block. Okay. Let's follow the steps. Step 1 said what? Assume they move together, right? Assume they move together. Correct. Find the acceleration of the system. So A will be what? Total force by total mass. Total force applied 90 Newton, given mass is what? 10 plus 30. So this becomes how much? 90 by 30. This is 20. So it becomes 3 meter per second square. Okay. So this is what your acceleration you have found. If they moves what? Together, then this is the answer. Okay. Yeah. Step 2 was like this. What was step 2? You have to write FBD of the block on which external force is not applied. Correct? Na? Write FBD of block on which external force is not applied. External force is not applied. And we have to calculate here. What you have to calculate in this step? We have to calculate the frictional force required to move. So this is the block where FBD is external force not applied, 10 kg block. So suppose moving this direction toward acceleration A. So frictional force, how frictional force will act? When you drag this block will try to slide backward, right? Backward means frictional force will act what? Forward. This block is trying to fall down, right? So it is trying to move in that direction. Frictional force act in what? Forward direction. Okay, so what we calculating here? Kinetic frictional force required to move. Correct na? So that will be equal to what? Ma, like last step we wrote, okay. Kinetic frictional force you want to calculate, write Ma. Mass of the block is 10, acceleration we have calculated somewhere here, that becomes 30 Newton. This is the force required to move, correct. Then you calculate what? Limiting frictional force. Limiting or maximum frictional force available. Now here you can confuse which body you will write to calculate that here, this body or that body, right. So this is directly simple. For this always what? Your top body, right now. Here you always you write the, in this case to find this limiting or maximum frictional force, write the always FBD of the top body. So look here, to find limiting kinetic also, because top body was here, no force applied, so in this step also we write FBD of that, here also we write FBD of that one only, correct na? Like last time force was applied here, so to calculate this value we write FBD of this, then to calculate maximum we wrote FBD of this, but in this case in both ways we have to write FBD of that block only, okay. So let's find maximum, what answer it comes, frictional force is equal to simply what? Mu into N, correct. Yes, mu into N means what? 0.4, and N of this block only I am saying is equal to mg, 10 into how much? G is what? 10. So this becomes what? 14 Newton. This is little important. Once more I am telling, already I wrote always top bodies you have to write FBD of the top body to find what? Limiting or maximum frictional force available, correct na? So this is important little, okay. So what we see here? We see that this force is less than that force, correct na? As kinetic friction is less than what? Limiting, correct na? Yes, is less. Less means the two bodies will move what? Together, correct. So the two blocks moves together, block moves together. And what is the acceleration? That acceleration. With what acceleration? With acceleration is equal to what? 3 meter per second square. So this question is done here itself, okay. Suppose this value was bigger than this, it also became suppose 40, this also 40, then you have to write the fourth step. You have to calculate what? Individual acceleration, right, by writing FBD. So done here itself, this is the answer. Okay, these were the main questions. Apart from this, suppose they ask some question like this way. Suppose they say that these two blocks moves together, then how much force we can apply here? Maximum force. So that blocks moves together, the F we have to calculate. So look, very simple. I write it here. Suppose two blocks are given to, this block M1, other block is what? M2, and this surface is again smooth, okay. This is smooth surface, and here is what? Friction is given, suppose what? Mu. Then said what maximum force I can apply here so that block moves together. So what is the question? What is the maximum force we can apply so that blocks moves together, correct. So what will the answer of this question? Simply F will be equal to your sum of these two forces M1 plus M2, add them into mu into G. That's a simple answer, correct. Okay. Or by chance they ask this type of questions, suppose again same block only M1, then this block M2 here, suppose this is tied to a wall like this one, right. Then they say that how much minimum force required so that this block start moving, M2, right now. Yes, so in that case what is shortcut answer? So what is the question? This minimum force required to move block M2. This is the question, okay. So what is the answer of this question? It will like here, suppose some friction is here, that's why calling mu1, some friction will be here, both surfaces are friction, mu2, okay. Then what is the answer? F will be equal to frictional force here plus F2, this will be the answer. And what will be F1, friction force due to this block, that will be what? Simply mu1 into what? Let me write correctly, M1G of that block. Then what will be F2? This will be what? Mu2 M1 plus M2 into what? G. Okay, this will be your answer. So these are shortcut answer I just told you. So what I am saying, these two block problems are not much important for as a NEET student, but still they are good if you are preparing. Okay. So this is here we complete our friction. We will discuss few problems based on what previous year in next lecture. Okay. Thank you.